Hello all, myself Ejazullah, lecturer mechanical department GP Western Betia. Today I am discussing about the concept second law of thermodynamics. After the attending the session, you are able to explain the feature of second law of thermodynamics, calculate the efficiency of heat engine, and third is calculate the coefficient of performance of heat pump as well as refrigerator. Prerequisite knowledge before going to attend this session, some topics to be covered. Thermodynamic system and state. We all know that before understanding the concept of second law of thermodynamics, the first of all you need to understand the thermodynamic system and state. Now the equilibrium concept, we already know that in the past classes we cover the equilibrium concept. Before going to understand the concept of the second law, we understand the concept of equilibrium. It means thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Now the third prerequisite knowledge are basic concept of energy and work, because we all know that in the thermodynamics the main aim of the thermodynamics is to convert the low grade of energy into high grade of energy. It means the heat is converted into the work. Now the fourth is temperature and heat transfer, because before going to understand the second law of thermodynamics, the temperature and the heat transfer is the basic concept, because any heat transfer occur only due to the temperature differences. Now the basic law of thermodynamics is the important prerequisite knowledge before going to understand the concept of second law of thermodynamics. Basic law of thermodynamics means you understand the concept of zeroth law of thermodynamics as well as first law of thermodynamics. In the short way, you know that the zeroth law of thermodynamics as well as first law of thermodynamics. Next slide is the content in this presentations. We focus on that area: introduction, basic definitions, the statement, Kelvin Planck's perpetual motion machine of second kind, heat engine, Clausius statement, refrigerator, heat pump, summary and assignment. Introduction. The second law of thermodynamics is the most important law of thermodynamics, because the all real condition to be depend upon the second law of thermodynamics. The first law of thermodynamics is not really possible. It is only so the not possible in the physical condition, but the second law is also called the physical law, because all the heat engine, refrigerator, heat pump are work on the basis of second law of thermodynamics. So on the basis of that, the second law of thermodynamics is also called directional law, qualitative law, and introduce the concept of entropy. The basic aim of the second law of thermodynamics to elaborate the concept of entropy and the significance of entropy. Now the basic definition before going to understand the concept of second law of thermodynamics, some basic definitions are required, and before going to analyze the concept of second law, some terminology are required to understand, such as thermal energy reservoir. The purpose, we all know that, we all aware about that reservoir. The meaning of reservoir is a storing unit. It means here the thermal energy reservoir, those type of the storing unit reservoir which store the thermal energy. It means it clearly define, it is defined as the sufficient large system in a stable equilibrium that can supply, absorb a finite amount of heat without any change in temperature. It means the thermal energy reservoir can supply or absorb a finite amount of heat, but in that conditions there is no change of temperature. There are two types of the thermal energy reserve. One is the source and now other is the sink. The purpose of source is to supply the thermal energy without undergoing any temperature of any temperature changes. Now the sink, the purpose of sink is absorb the thermal energy without undergoing any temperature changes. Now in this image we can clearly see that the hot source and the cold sink. It means the purpose of source is it maintains, always maintain the temperature higher, and the sink is maintain temperature the lower. Higher temperature TH and the lower temperature TL. Now this is the process. The hot source, it means source supply the heat energy QH without undergoing any temperature in the TH. Now the some part of the This heat is in the real conditions is converted into the work by the heat engine, and now the remaining is rejected to the sink. It means the QL amount of the heat is rejected by the heat engine, and that can be absorbed by the sink, but there is no change in temperature in the sink. There are two statements of the second law of thermodynamics. The one is Kelvin Planck's statement, and the other is discussed on later. Now the Kelvin Planck's statement, this is most important statement of the second law of thermodynamics. It states that it is impossible to construct a device that operates in a thermodynamic cycle, produce no effect other than the work output, and exchange heat with the single reservoir. It means it clearly say that there no any real heat engine can be operated with a single reservoir. If this can be possible, it means it violate the statement of the Kelvin Planck statement. कोई भी हीट इंजन सिर्फ एक सिंगल रिजर्वायर के साथ काम नहीं कर सकता है. जैसे कि इस इमेज में आप देख सकते हैं, देयर इज सोर्स, this is the heat engine. Now the completely heat supplied by the source is converted into the work. This is impossible for the Kelvin Planck's statement. Now this is the possible cycle because some amount of the heat is converted into the work and remaining is rejected into the sink. Now the next, the perpetual motion machine of the second kind, it is the violation of the second law of thermodynamics. It device that violate the second law of thermodynamics is called ppm2. It means when the complete supply of the heat is converted into work, it means the efficiency of this cycle will be the 100%, and it is never possible in the real world application. From here, the equation we understand, the efficiency is the work output divided by the heat supplied. That W net is converted into WQ1. It means that the efficiency is 100%. If the machine can be 100% efficient, it means it is never possible in the real world application, and this is the violation of the second law of thermodynamics. This is called perpetual motion machine of the second kind. Now आप यहाँ से देख सकते हैं
machine of second kind. Consider a piston cylinder arrangement which receive a heat of 50 kJ from a thermal reservoir and also produce a net work of 50 kJ. We can see that this arrangement is not rejecting any heat, which means it is not following the second.
And this is the example of the perpetual motion machine of the second count. You can understand from the here demonstrations. Now the 50 kilojoule of the supply, and that all heat is converted into work. It means there are no losses of heat. If there are no losses of heat, it means the complete heat input is converted into the complete work. It means the efficiency of this heat engine is 100%, and it is never achievable. So this is the called ppm2, and this is the violation of second law of thermodynamics. The next slide, the heat engine. The basically the two statement of the second law of thermodynamics, one is the Kelvin Planck and the another is Clausius statement. In the previous slide we already discussed. After attending the session, now you are able to understand the concept of heat engine as well as heat pump and refrigerator. On the basis of two statements, the first statement, Kelvin Planck's statement, the real application of the Kelvin Planck's statement in the heat engine. The heat engine is a mechanical device. We all know that because it's a part of thermodynamics. It is defined as a thermodynamics device used for continuous production of work from the heat when the operating in a cycle process is called heat engine. It means the second point, it receives the heat from the, आप यहाँ से देख सकते हैं, it receives heat from the source higher temperature, and the third point, it converts the part of heat into work by the applications of the heat engine, and the work is converted W equal to Q1 minus Q10, and the remaining part is rejected to the sink. Now the efficiency of this heat engine is, it means the basically heat engine is a device which convert a heat supply from the source, a part of heat supply from the source is converted into work, and remaining is rejected to the sink. Now the efficiency is desired work output divided by required heat input, the W net divided by Q in, and this can be, we can calculate. On the basis of that, you can also solve the numerical problem. These are the basic things. Now, example, during जैसे कि इस एग्जांपल में आप देख सकते हैं, नाउ द हीट सप्लाई इज 500 जूल, रिजेक्टेड इज 300 जूल। तो आप यहाँ से इफिशियंसी कैलकुलेट कर सकते हैं हीट इंजन का। द एफिशिएंसी इज, we all know that efficiency is 1 minus q2 by q2. Putting this value, now this get result. The efficiency of this heat engine on the basis of given data is 40%. Now the second most important statement of the second law is Clausius statement. It gives the two statement, one for the refrigerator and the second for the heat pump. The refrigerator as well as heat pump is work on the basis of the Clausius statement. It is, ये क्या कहता है, it is impossible to construct a device that operate in a cycle and produce no effect other than the transfer of heat from the lower temperature reservoir to higher temperature reservoir. ये कभी भी पॉसिबल नहीं हो सकता है कि हीट ऑलवेज फ्लो फ्रॉम द लोअर टेम्परेचर टू हायर टेम्परेचर विदाउट एनी एक्सटर्नल इनपुट। इफ दिस कैन बी पॉसिबल इट मीन्स इट वायलेशन ऑफ द क्लॉसियस स्टेटमेंट। जैसे कि आप इस डायग्राम से हम लोग समझ सकते हैं, this is the source and this is the sink. The q2 is directly supplied by the end of q2. It is impossible. If this can be possible, it means some external work are required to supply the heat from the lower temperature to higher temperature. Now this is the possible cycle. The q2 is moving forward by refrigerator and by the external input. The refrigerator. Refrigerator is a mechanical device. The refrigerator and heat pump is similar. The refrigerator is used for basically to preserving the food and it maintain the temperature below that the surrounding. जैसे कि आप देख सकते हैं, the purpose of only refrigerator to here the space being cooled, our food preserved to be here, and the temperature of this is to always maintain the below atmospheric temperature, because our desired output, the desired effect is to be maintain the temperature below the surrounding temperature. तो यहाँ से आप हीट रिमूव कर रहे हैं वर्क इनपुट से एंड इट कैन बी सराउंडिंग, इट मीन्स द एम्बियंट टी इज द सराउंडिंग टेम्परेचर इज एटमॉस्फेरिक टेम्परेचर। आप यहाँ से कोएफिशिएंट ऑफ परफॉर्मेंस कैलकुलेट कर सकते हैं। कॉप ऑफ द रेफ्रिजरेटर इज नथिंग बट desired output to the required input. The desired output is nothing but it is the refrigerating effect. It means we require to maintain the temperature below that the surrounding. In the previous we the focus on the removing the heat from the sink. It means the lower temperature maintaining Q2 divided by W net. W net is know that Q1 minus Q2, and now the COP is desired effect Q2 divided by Q1 minus Q2. Now the heat pump. The purpose of heat pump is to maintain the temperature above the surrounding temperature. Here we know that the T is greater than T atmospheric. The purpose of this can be used for the cold places where the room temperature, the heat required to maintain the more as compared to the atmospheric temperature. आप इस डायग्राम से देख सकते हैं। नाउ द कॉप इज आवर गोल इज टू बी द heating effect, not with the cooling effect. It means we require the more heat and we require to maintain the temperature above the surrounding. So the COP is Q1 divided by W net, and W net Q1 minus Q2. COP of heat pump is equal to Q1 divided by Q1 minus Q2. Now the most important relation between the COP of heat pump and COP of refrigerator is COP of heat pump is equal to the COP of refrigerator plus 1. The COP of refrigerator is lies between the 0 to infinity, but the COP of heat pump is lies between 1 to infinity. These are the most important things to correlate with the COP of heat pump as well as COP of refrigerator and solve the problem on the basis of that. Now the summary of this session is the second law provides the direction for the thermodynamics process, because we know that the heat is flow from lower to higher. If the some external heat work are required, it means it show the direction on the basis of that you call the second law is called directional law. Heat naturally flow from hot object to cold ones. You can understand from the previous slide. No energy transfer is 100%. If the energy transfer is 100%, it means it is not a real conditions application. It is impossible. So from this point can be understand from the Kelvin Planck's statement by PMM2 concept. The second law implies that the entropy of the universe is always increasing. Now on the basis of this session, the assignment is here. now you are able to solve, and you are able to understand the all concept on the basis of second law of thermodynamics. On the basis of concept, you can solve all the problem related with the assignment. Now you able to answer the all questions. Define the second law of thermodynamics. There are two law of thermodynamics, Clausius and Kelvin Planck. You can define, explain how the second law of thermodynamics limit the efficiency of the heat engine. With the help of PMM2, you can elaborate the this concept heat engine. Now you can solve the problem given that, calculate the maximum gas, all this to be calculated. Thank you. I hope you can understand the concept of second law of thermodynamics, and this session is very useful for all of you.